Okay, so let's talk about LLMs, large language models. They're amazing, right? But their outputs can be all over the place. If you're a developer building AI apps, you've totally been here. Everything's great in development, but then you push to production and weird things start breaking. It's almost always because of these subtle data errors from the LLM. So let's dive in and figure out how to tame this chaos and build AI systems that, actually work in the real world. Okay, check this out. This really shows the problem in a nutshell. On the left, you've got this perfect JSON our app is hoping for. It's clean, it's structured, all the data types are right. But on the right, yeah, that's what an LLM might spit back at you. It looks almost perfect, right? But take a closer look at that risk score. It's a string, not a number. This tiny little thing, it's a ticking time bomb. It can lead to silent data corruption or just crash your entire app at the worst possible time. And this really gets to the core of it. If you're just taking that raw, unvalidated output from an LLM and plugging it into your system, well, that's not just risky, it's a huge production liability. We absolutely have to have a systematic, bulletproof way to enforce structure and make sure the data flowing through our pipelines is clean. So in this explainer, we're going to tackle this head on. First, we'll really define the problem, then we'll introduce our hero, Pydantic. We'll build up a practical validation toolkit, see how it plugs into real AI workflows, talk about the crucial upgrade to Pydantic V2, and wrap up with some key takeaways you can literally use in your code today.
All right, so how do we actually solve this? Let's bring in our tool for the job. Think of Pydantic as the gatekeeper for our data. It's going to make sure that only the good, clean, valid information ever gets through to our application. So what is Pydantic really? At its heart, it's a Python library that does something brilliant. It uses the standard Python type hence you're already writing to do all the heavy lifting. It takes messy data, like that unpredictable JSON from an LLM, checks it against a schema you define, and if everything lines up, it hands you a clean, predictable Python object that you can actually trust in your code. No more guesswork.
And the workflow is just beautifully simple. You've got your raw, unreliable data coming in from the LLM. It hits your Pydantic model. That model acts as the bouncer at the door, the gatekeeper. If the data is good, it gets transformed and passes through as clean, usable application data. But if it fails validation for any reason, nope, it gets rejected right there before it can ever cause any damage downstream. Okay, theory is great, but let's get our hands dirty. It's time to actually build out our validation toolkit. We're going to start with the simple stuff and then work our way up to the more complex, really powerful techniques that every single engineer working with AI data needs to know. All right, let's look at some code. Here we have a fraud record model. The magic part here is this @FieldValidator decorator. This is how we tell Pydantic, hey, for this specific field, run this special logic. In this case, for the MSISDN field, we're running a custom function to check if it's a valid Indian phone number. It's just a really simple, clean way to bake your business rules right into your data model. Okay, what about when one field depends on another? This is super common. Take a look at this risk assessment model. Our validator here is looking at the decision field, but it's also checking the risk score. So now we can enforce a rule like, hey, you can't have an allowed decision if the risk score is over 0.8. This is awesome for making sure your data is not just well-formed, but logically consistent. And here's another fantastic example of that same idea. In this geo-fraud check model, we're comparing the phone country to the IP country. If they don't match, which is a classic red flag for fraud, we can dynamically bump up the risk multiplier. See? This isn't just about rejecting bad data anymore. It's about embedding actual business intelligence right into your data structures.
Okay, let's talk performance. Not all checks cost the same amount of time and resources. This external validation pattern is pure genius. It's a layered defense. First, it runs a super fast local rejects check. It's cheap. Only if that passes does it bother to make the much slower, much more expensive network call to an external API. This fail-fast strategy saves a ton of time and money in production.
And this validator priority metrics really gives us our strategic roadmap. You always start with the cheapest, fastest checks on the left, like format validation with regex. These will catch most of the simple errors. Only after passing those do you move on to more expensive checks like business logic, cross-field rules, and finally the real heavy hitters like calling an external API or another ML model. But does this stuff actually work in the real world? Oh yeah. This table shows the results from a live telecom fraud system. Just using a simple regex on the phone number, that alone caught 85% of the garbage. And look at the PII blocker, 100% compliance with 0 false positives. This isn't just theory. This stuff is battle-tested, and it just plain works. So,
We've built up our toolkit of individual validators, right? We have simple field checks, complex layered defenses. It's great. But now let's zoom out. How do we plug these powerful tools into bigger, more complex AI systems, like those multi-step agentic workflows everyone's building?
Okay, listen up, because this is probably the single most important architectural tip in this whole explainer. If you're building stateful AI agents, maybe with a library like LangGraph, you have to validate the LLM's output at every single node boundary. The flow has to be raw LLM output, it goes straight into your Pydantic validator, that validator creates a clean state object, and only then do you pass it to the next node. This is how you prevent one bad LLM response from poisoning the entire agent's run.
And here's what that looks like in actual code. This validate LLM node function is the perfect blueprint. It calls the LLM, but then it immediately wraps that output in a try-except block and tries to parse it with our Pydantic model. If it works, great. The agent's state gets updated with clean, validated data. If it fails, the accept block catches it, stops a crash, and lets you route the agent to an error-handling path, maybe for a human to look at.
Now, what if you want to automate this whole retry loop? Well, the instructor library is an absolute game changer. It cleverly patches your OpenAI client and lets you specify a response model. So if the LLM's first answer doesn't validate against your Pydantic model, Instructor automatically reprompts the LLM, feeding it the validation error and basically telling it, hey, try again and fix this. This creates these amazing self-healing data pipelines with almost no extra code.
All right, let's get real for a minute. Technology moves fast, and Pydantic is no different. The jump from version 1 to version 2 brought some pretty big breaking changes. For any engineer who's maintaining a production codebase, you need to know how to migrate your validators. It's super important.
Okay, the most common change you're going to run into is this one. In V1, you use the @validator decorator for your single field checks. In V2, that's been renamed to the much more descriptive @field_validator. It does the exact same thing, it's just clearer about what its job is. Honestly, this change will probably be like 90% of your migration work.
And for that cross-field logic, V1 had this thing called @root validator. V2 replaced it with the more intuitive @model validator. You usually use it with mode equals after, which means it runs after all the individual fields have been validated. It's perfect for putting in those cross-field business rules we were talking about earlier. Feeling a little overwhelmed by the changes? Don't be. This migration checklist is your best friend. Seriously. It gives you a direct one-to-one map of every major pattern from V1 to its new home in V2. Validator becomes field validator. Root validator becomes model validator. It's a super clear and simple guide to get you through the upgrade. Woo! We've covered a ton of ground. So let's wrap this up by boiling it all down to the most critical, actionable takeaways that you can go and put into practice in your production systems like right now.
Okay, here are the pro tips. Rapid fire. First, always use model_validate JSON on raw LLM output. It does parsing and validation in one go. Second, for things like status fields, use literal types. They create these strict self-validating enums. Third, for any kind of score or probability, lock it down with field GE equals 0.0, LEA equals 1.0, so you never get out of bounds values. Fourth, on your most critical paths, use Instructor to get those automated self-healing retries. And finally, the golden rule. Never, and I mean never, pass unvalidated data to your downstream models or your database. Ever.
So, let's end with this thought. At the end of the day, your AI is only as smart and only as reliable as the data it's running on. Pydantic gives you all the tools you need to guarantee that quality. So the only real question left is, how are you validating yours?